Hello all, this is Anita. Welcome to the machine learning video lecture series. So today in this particular video we are going to discuss the Bayes theorem and the conditional probability. So this particular video is divided into the two parts. So in this video we will see the dependent event, independent event, conditional probability and how to derive the Bayes theorem. And then in the next video we will discuss the naive Bayes classifier where this theorem is used. So let's get started. So first we will see what is independent event. So independent event are those events whose occurrence is not dependent on the any other event. Or we can say if the probability of occurrence of event A is not affected by the occurrence of the another event, that is B, then A and B are said to be the independent event. For example, tossing a two coin independently. So here if we toss a two coin independently, so probability of getting head or tail is the 1 by 2. So here both the event are independent to each other. They are not depend on each other. So there we basically consider this as an independent event. Or in another example is the rolling a die. So here if we are rolling a die three times, so we are interested in calculating the probability of getting three yes in a row. So it will be 1 by 6 into 1 by 6 into 1 by 6. So first row does not impact the probability of getting a 6 in the subsequent row. So again this is an example of the independent event. So the next one is the dependent event. So dependent event are those events that are affected by the outcome of the event that had already occurred previously. That is, two or more events that depend on one another is known as a dependent event. So when the occurrence of one event affect the occurrence of the another subsequent event, then the two events are the dependent event. So here we will see one example, that is the probability of finding a black ball from a box of three red ball and the two black balls. So changes if we take out the two balls from the box. So here we can see that we are considering the first event as the picking up the one black ball or marble we can say, and the second event is the pick up one more black marble after the event A. So here you can see we are considering the event A as a pick up the black ball or the marble. So out of the 5. So here 3 red ball and 2 black ball. So what is the probability of event A, which is equal to 2 by 5. So 2 black, and out of that I want to pick up the 1. So that is 2 by 5. Now after occurring this event, in the next I want to perform the event B. So here what I have written, the probability of event B given A. So here A is already happened and the B is like I want to perform. So in that case the probability is 1 by 4, because after getting 1, so now remaining 1 are the 4, and out of that 4 I want to pick up the one black ball, which is again 1 is remain. So 1 by 4. So this is how the one event is dependent on the another event, and the occurrence of this event is affected due to the occurrence of the previous or the earlier event. So this is called as a dependent event. Now we will see what is the conditional probability. So conditional probability is the probability of an event occurring given that another event has already occurred. Or we can say like when we want to calculate the probability on a condition. So that is a conditional probability. So again we are considering the same example here. So with this you can see this one is probability of A given B. So this we are reading it as a given. So here the this is the conditional probability, because the probability of the A event occurring given that another B event, and that B event is already occurred. So here we are calculating the probability of A given the condition, and that condition is the B condition. So this is what the conditional probability. Now, what is the formula of the conditional probability? So here, if I want to calculate, so in the previous example, you can see that here the probability of A and B, that the probability of both A and B event taking place. So if you want to calculate this probability of both event A and B taking place, so what we are doing, we are multiplying these two. So here you can see the probability of both event A and B taking place is equal to probability of A by B into probability of B. So these are the dependent event. So here B is all probability of B. So this B is already taken place, and I want to calculate the probability of event A based on the event given the B. So these are the dependent events. So this is the formula for the dependent event. Now, based on this, we are calculating the conditional probability. So, this is the formula of the conditional probability. Probability of A given B is equal to a probability of A and B and divided by probability of B. So, this is the formula of the conditional probability. Now here you can see that this probability of A by B is the probability of happening if event A and B has already happened, or it is say conditional probability of A given B. Now we will see how this Bayes theorem is derived from the conditional probability. So this Bayes theorem, which was given by the Thomas Bayes, a British mathematician in the 1763. So this Bayes theorem describes the probability of an event based on the prior knowledge of the conditions, and that might be related to the event. So here the Bayes theorem is derived through the conditional probability formula. So the Bayes rule can be derived from the following two equations. So here for calculating the Bayes theorem or deriving the Bayes theorem, we are calculating the conditional probability of the A given B. So first we are calculating this conditional probability of A given B. So here you can see conditional probability of the A given B is equal to probability of A and B divided by probability of B. So this is the equation number 1. Now we are calculating the conditional probability of a B given A. So reverse we are finding. So here you can see the formula probability of B given A is equal to probability of A and B divided by probability of A. So this is equation number 2. Now from this equation 1 and 2 you can see this probability of A and B and this probability of A and B, or if we return here to B and A. So both are similar. So we are equating these equations here. Um, so you can see here from that equation 1 and 2 we are equating these two, and after this we are getting the Bayes theorem. So this Bayes theorem gives us the conditional probability of the event A given that the event B is occurred. So here simply what we are doing, we are keeping this here, and this we are going as a denominator in this formula. So simply that we are doing here, and after this we are getting the Bayes theorem formula. So here you can see this is the final Bayes theorem formula. So for this probability of A by B, it is called as a posterior probability, and the probability of B by A, so this is called as a likelihood, and probability of A is the prior probability of the event A, and probability B is the marginal probability of that event B. So all these are the terminologies related to the Bayes theorem. So this is how we can derive the Bayes theorem from the conditional probability formula. And now we are using this Bayes theorem in the naive Bayes classifier. So now take a pause here and tell me how is the Bayes theorem is applied in the real world scenarios. And after done, resume the video. So here this Bayes theorem can be used in the multiple applications, but I have taken here one that is in the medical diagnosis. So the Bayes theorem helps update the probability of the disease given the certain symptoms, and based on the prior knowledge of the prevalence of the disease and the likelihood of the symptoms occurring. So this is the one of the application where we can use the Bayes theorem So this is all about the Bayes theorem and the conditional probability. Thank you.